Yeah.
As many can attest, when you join the Globebusters community, you are given a new set of eyes. Now, we've studied Earth science before, but now that we've been given a new set of eyes, it is time to go back and tell you what we see. This is modern Earth science destroyed.
You're not going to believe this. In science, we always say that you make observations, you have a theory, you go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
I've got one that can see.
He's a tall Caucasian male, doesn't appear armed, wearing sunglasses.
I don't like this one bit. Not one bit.
Whew, that just gives me tingles.
Awesome.
Thank you. Yeah, I had to do that for Conspiracy Awareness Day today, 9/11.
You made that?
Huh?
Did you make that? Did you edit
Yeah.
that video?
Yeah,
Sweet.
yeah. Kind
Fair
of.
enough.
We've been using the first half of it for a while now, and then I just added that last little bit of him going through like, I don't like this one bit. I'm like, yeah, because I feel like that's kind of so many of us right here after having our eyes opened to all of this. Kind of all we go around and we see all the bots kind of start showing up, and how dare you say such a thing, or start to claim to see anything. The funny thing about that movie, They Live, is it has, or at least from what I heard, had like one of the longest fight scenes of its time in that movie, and that was kind of a big thing. And I feel like it's so many of us. I just want you to see, and so they get into a big, huge fight over just put the glasses on and take a look, and he wouldn't do it. And yeah, so after this big, long, extensive fight scene, all of a sudden. He finally puts on the glasses and then become friends after that. It's kind of a weird thing, but yeah, not that. I'm not here to troll anyone, though. Or I'm not gonna force anyone to try to see anything like that. But we really do our best to try to open people's eyes.
Absolutely. It's symbolic for the battle we go through with our friends.
Yeah. So I haven't introduced you yet. So
Yeah.
everyone, this is Kevin Bobick. Kevin, and yeah, this is Kemi. Kevin. So hello.
Hi, Kevin. Very, very nice to meet you. Thank
Good
you
to
for
meet
coming
you.
on tonight.
Thank you.
Yeah, it's 9/11. Do you all remember where you were the day it happened?
I was in school at the time, art class.
I just lost it. I'll be back.
Okay. Okay, she'll be right back. She's been having some audio issues lately, kind of cutting in and out. Can you hear me all right?
Yeah, I can hear you fine.
Okay, great. So, yeah, we've been talking kind of on and off for about 2 years now. Ever since I saw a video with you and your daughter. She was doing this big flat Earth presentation, and that was 2 years ago. So, yeah, back then she was 8, so she's about 10 now.
She's 11. Yeah.
Oh,
it's
11.
been a while.
Okay. Yeah, it has been a while.
Uh-huh.
Cool.
Yeah.
Yeah, I was going to try to get my daughter. Right, she's kind of busy right now working, but yeah, I would love to get her in here. Hello. So, let's see if Kimmy's back yet. Hopefully she'll come back real soon. So, about that video, would it be all right if we shared that real quick?
Absolutely. My daughter's
Cool.
video?
Yeah, I've got it right here. I can go ahead and share it, and I feel like that's a really good introduction for you.
Yeah, sure.
Let's get. Share screen. Share. So I'm going to go ahead and share your video real quick, and this is back when she was 8.
Hi, my name is Bamery Bobbitt, and I'm 8 years old, and I'm going to be teaching you about
Can you hear it all right? Last time we were having some audio issues.
It's a little low, but
I wonder if I can do anything to turn it up.
flat Earth. So first we're going to start off with gravity. Gravity is a theory, not a fact. Mass attracting mass never been proven properly. This happened in 1660.
Any better?
An apple fell on Isaac Newton's head. It must
I
have
can
been
hear
a
it's just
big
a little low.
apple for him to believe in gravity. Gravity is fake because density and EMF are making things drop, not gravity. There is iodine salt in this cup and no iodine salt in the other cup. There is 2 cups of water with an egg. One with iodine salt, one with no iodine salt. This one has iodine salt and it has electricity because electricity is pushing the egg up. On the other one, it has no electricity in it because the egg is denser than the water. Density and surrounding medium with EMF. That stands for electromagnetic frequency. If gravity can't be proven and Earth is 70% water, we know water stays level, then 70% of Earth is level. Now we are going to move on to the globe and our flat Earth. So say there's a boat just cruising on the bottom of the Earth. It would fall into space, and space is fake. If space was real, stars would have parallax, but they don't. So it would just fall into space. And this is for anything that can't go upside down. If people believe that the Earth is round, people don't walk upside down. Same with a boat. It doesn't sail upside down. They think this is true on that. Well, no, it is not. This is our true flat Earth. And the thing around it is the firmament. I'm going to tell you how the firmament is real. The firmament is real because air pressure has to be contained, just like in a tire. Now we are going to move on to seasons and the sun. The spinning ball globe believers say that the sun is 93 million miles away. The globe depends on parallel rays for the seasons. All you have to do is use your God-given eyes to see we have corpuscular rays from the sun. Corpuscular rays proves we have a local sun. That proves everything about seasons and the sun. Now we are going to move on to a sun, moon, and earth depiction. The sun is shining on the moon and the moon is shining on the earth. Why is it not shining its temperature on earth? Well, me and my dad did an experiment one night on a full moon, and we used a laser thermometer to check the moon's light and its shadow. The moon's light was colder than its shadow, so that proves the light is colder than its shadow, and proves that the moon has its own light. The sun is not reflecting its light on the moon. The moon has its own light. Thank you for watching my flat Earth presentation. I hope you guys liked it. And Jesus Christ is the way, the truth, and the life. Just remember, the truth does not fear investigation. Thank you for watching. Bye.
Yeah, I absolutely love that. How long did it take you to kind of plan that and put that together?
it took a while. Like, we did a lot of rehearsing, and then... can you hear me
I
okay?
heard. I don't know if
I
you
can
can
hear you.
hear me. I heard her at the very end. As soon as you started talking, I lost it again. I might just go in. Well, I can listen to the chat and you can leave me on. I don't know what it is, Cal. It keeps
I don't
dropping.
know.
I'm going to watch in the chat. You can tell me to jump back on if we have something. I'm just going to watch in the chat.
Okay.
real quick to
We can hear you just fine, just so you know. We can hear you just fine.
So I'll do that.
Oh, yeah. Oh, man, that sucks. Well, yeah. Sorry, not a very good introduction there with Cammy. They're really trying here, though. But, yeah, there's always next time, and hopefully we'll get this figured out eventually. But, yeah, I was going to ask you about how long that took you to kind of get that all put together, because a lot of that looked like memorized.
Yeah, she basically had the whole thing memorized by the time we were done. And it wasn't like first time, first performance. Like, we did it a few times until she got it just right. But I would say it took, I don't know, maybe a couple weeks or something like that. Maybe a week. I don't know. Like, it's been so long. So, but it was super cool whenever she did it. After she did perform it, I'm not gonna lie. Like, I think I had some tears of joy after she performed it the way she did. Like,
yeah, I think like. Just for myself, and I'm sure lots of other people out there too are like, yeah, just kind of cheering for her. Yeah, I'm sure you got a lot of that in the comments and stuff. Yeah. How has things been with school for her? Other people receiving her well? Has there been any kind of backlash at home?
no, well, not with me anyway. Her mom is not with it. I don't know if she'll ever be, but that's her own prerogative. So
yeah,
but she was actually like openly talking to her friends at school about it, like after that had happened, and I think it really helped build her confidence on the subject. You know what I mean? Like, hey, I'm right.
Being able to answer the questions. Yeah.
Yeah. So she well, I remember she was telling me a while ago she had a conversation with her friend about the moon being a projection, and her friend was like, "Oh yeah, I believe it." Yeah.
Yeah, that's really fun when they actually know more about the topic than all their other peers do, and that definitely sends the confidence level through the roof there, because when she spent more time actually looking into it and asking the questions, that's huge.
Yeah, absolutely. And like that presentation, like it was pretty basic, you know what I mean, but I made sure the information that she was portraying like couldn't be attacked. So like people were saying, "Oh, what a bad dad I am for teaching her this," and all of the negative comments. There's a bunch of ones, but
there's tons of trolls out there.
They weren't attacking the information. You know what I mean? It's like okay, like
I hear you entirely.
Yeah. Hey, can you pick out one subject that she went over that you can debunk? And like, no one was able to do that. So
cool. Yeah, I've been having a lot of fun just kind of getting my daughter more involved. We just did a big, huge debate over at our local library against everywhere, and my daughter did a great job with that. And she felt a lot more confident, and she just felt really proud of herself afterwards, and I was too. And that's one of the things that has been standing out to me lately is the word honor. And when I went and told my kids this after I walked them to school the other day, and I just told them, "You honor me." And my daughter kind of tilted her head and looked at me. My second youngest, because she's in first grade now, and she kind of tilted her head and kind of like, "You don't normally talk like that." And so she kind of smiled though. She's like, "Huh?" But yeah, if we never tell our kids, "You honor me," then how are they going to know what honoring your father and your mother looks like? You know what I mean?
Absolutely. Yeah.
Yeah.
It's been example. Love it.
Yeah. Kind of letting them know kind of that love and respect that you have for your parents, that you actually show it. And it makes a difference. So that's been one major thing that's been really standing out to me lately, is just kind of letting them know that when they do a good job of, just kind of showing a love and respect for us,
Absolutely. Hey, Bea, you honor me. She smiles.
Yeah. So we've been doing a textbook review. It's kind of what we've been doing here with this Modern Earth Science Destroyed series. And I'll go ahead and show you what we're looking at this week. This week we're talking about recording earthquakes. And can you see this? Can you see this? All right. All right, cool. So this textbook is talking about seismographs and about how seismographs record things. And we've got, I'll just go ahead and read this. Vibrations in the ground can be detected and recorded by using an instrument called a seismograph, such as the one shown right here. A modern 3-component seismograph consists of 3 sensing devices. One device records the vertical motion of the ground. The other 2 devices record horizontal motion. One for east-west motion and the other for north-south motion. Seismographs record motion by tracing wave-shaped lines on paper or by translating the motion into electronic signals. The electronic signals can be recorded on magnetic tape or can be loaded directly into a computer that analyzes seismic waves. A tracing of earthquake motion that is recorded by a seismograph is called the seismogram. And this is just the high school textbook that's kind of showing you that. And then I've got the college textbook over here, which is also showing you that. And one of the things that really stands out to me here is what the textbooks are not telling you. And so this is kind of what they're talking about, like the vertical motions. And we see a pendulum here. That's kind of the big thing. So this is just Wikipedia, and they're kind of showing you the basic mechanic of how seismometers work. And this is what they did before they got all fancy with the electronics. But this part here is really significant, the way they did that. And here I go right over to the NOAA. Let me show you their website real quick. Share screen. Okay, you can see this is from the NOAA, which is a big alphabet soup company. NOAA stands for the National Oceanic and Atmospheric Administration. Okay, one of the big things. And this is what they are showing us when it comes to seismology. And yeah, this is seismometers. And so we've got this pendulum, and it's connected to the ground, and as the ground wiggles and moves with an earthquake, it detects that, and sometimes it can just be little tiny things that we can't even feel, but this is able to detect it, and it's got a pen on there that ends up scribbling on this rotating drum, and that's where you see the waves. And I like the other one because it showed the vertical waves too. So this is one kind that does the horizontal waves, and then the other one does the vertical waves. Do you have any thoughts on that?
Well, you would think how sensitive it is. Like, why don't they use that instrument to measure Earth's motion? You know?
Yeah.
And I was actually looking over the inconsistencies of seismometers. It actually comes from external and internal noise sources, variations in instrument design and calibrations, and installation methods, and the influence of the data recorded. These factors mean that no 2 seismometers will ever produce identical measurements, even when placed next to each other. So I thought that was funny. If it can measure an earthquake and it's that sensitive,
no 2 seismometers will ever record the same thing, even when placed right next to each other.
That's what it says. Yeah.
Where'd you read that one at? That sounds interesting.
I just looked up the inconsistencies of a seismometer.
That's interesting. That really grabs my attention because people are. That was one of the things we talked a little bit about last week. Was about how you determine the location of an earthquake, locating an earthquake. This talks about that and how they kind of try to determine where it's at by, let's see, where did it say? Arrival times. To determine the distance to an epicenter, scientists analyze the arrival times of P waves and S waves. And so they've got different seismometers in different locations, and they just kind of judge it off of that. But you're saying that no 2 seismometers end up recording the exact same thing. So, and this kind of goes into what we were talking a little bit about last week, where I was pointing out how if you rub two cinder blocks together, you're going to get vibrations all up and down the entire surface area that are to rubber. Each point of contact, you got points of contact going all along this fault line. And so it's not just one point, and yet they're trying to say, oh yeah, the earthquake comes from like pinpoint location, and that's exactly what they're talking about when it comes to locating an earthquake. It all comes from this one little point. I can imagine how sometimes there might be like a cave collapse or something like that. Then that would be like a more of a pinpoint type earthquake, or kind of an underground explosion where they're doing a mine or something like that, and they blow something up, and that could create like a pinpoint example. But you take two big blocks and you rub them against each other, you're going to get vibrations all up and down those blocks. It's not going to be pinpoint at all. And so, yeah, your whole inconsistency thing just lines up really well. Rings a bell.
Yep.
So, looking at this, I was pointing out or I guess you pointed it out too, the pendulum. Right? Have you heard much about pendulums when it comes to proving the rotation of the Earth?
Yeah, it's funny. I think it's kind of a silly theory, but like they want to pretend that the atmosphere is connected to Earth, but then on the other hand, they're like, no, the atmosphere is not connected to Earth, and that's why we can actually test Earth's motion with a Foucault pendulum. And I'm just like, dude, you can't have it both ways. You know what I mean?
Yeah. Let's see here. I've got. Let's see. I already shared the one from NOAA. So let me share this quote from Brian Cox. Hopefully you can hear it.
Can you hear it? Because the volume's real low still.
It's okay. Can you hear it now?
If I turn it up real loud, yeah.
Okay. Sorry, I don't know how to fix this audio issue where the videos I'm trying to share. The only way I can think about fixing it is maybe just downloading all my videos in advance, the clips I want to share, and then that worked because the opening intro that seemed to work just fine. So I'll come a little bit more prepared trying to do that. The hard way next week is having a downloaded video to share with everyone. But anyways, with that clip from Brian Cox, he was saying that pendulums don't prove whether you're moving or not. And a lot of people say, oh, well, that's only talking about rotating around the sun. And that's the big claim with Brian Cox, when he's acknowledging that there's no experiment you can do to tell whether you're moving or not. I'm like, okay, that means there's no proof that the Earth is moving.
That the Earth is in motion, right?
Yeah,
It's
in
like-
motion.
Yeah, so they say that one of the other proofs is the Coriolis effect, right? There has to be a cause and an effect, right? There has to be a causation for the effect. But then you ask them, like, okay, well, where's the cause and effect for Earth's elliptical orbit? Where's the cause and effect for the corkscrew motion following the sun at 500,000 miles per hour? Where's the cause and effect of Earth's precession? You know what I mean? It's like, oh, there's only one cause and effect to the least significant motion in the solar system. I just think it's funny.
We all know Earth is
Okay.
flat.
Can you hear this one now? Maybe it's just the video. So I was going to share a little clip from this, and hopefully that works.
Let's place the pendulum on top of the North Pole. Now imagine the ball bobbing back and forth while Earth beneath it spins counterclockwise. From this perspective, the pendulum is fixed while Earth rotates beneath it. No mystery here. But let's observe from the surface of the planet next to the pendulum. From this perspective, it's the pendulum that rotates while we perceive Earth to be stationary. Furthermore, the pendulum will be rotating clockwise once every 24 hours. This effect will reverse itself if the pendulum is on top of the South Pole. So from over the South Pole, Earth spins clockwise while the pendulum remains fixed. But if you're standing on the surface, it's the pendulum that spins, specifically counterclockwise. But what?
Okay. I don't know if you could hear that very well,
Yeah,
but I can.
That one just fine.
Okay, maybe it's just the video. Just one video works better than the other. I don't know. But here he's going on talking about the two different frames of reference. That's a big thing here. The different frames of reference. There's the frame of reference where you're stationary and it's the pendulum that's moving, and then there's the one where the Earth is spinning, and then it's the pendulum that moves. So, do you know what an absolute reference frame is?
No.
Okay, so Einstein, when he presented his whole theory of relativity, he said that there's no absolute reference frames at all. A reference frame is one reference frame that's superior to another reference frame. Apparently that was a thing when it comes to like Newtonian physics. And so you've got a merry-go-round, and you got a person who's just got a camera on the merry-go-round, and for that person and the camera who's spinning, for them it looks like the whole Earth is spinning around them. And then there's the person who's pushing the merry-go-round, and he's like, no, that guy is obviously the one spinning. Mm-hmm. And so with Einstein, he says there's no absolute reference frame. Those two reference frames are equal. For one person, there's no way to prove that it's not the Earth that's spinning during that whole time versus the person who's pushing the merry-go-round. Because, it's really that wild. And for me, I can't get on board with that at all, because with the absolute reference frame, you can tell because one guy is pushing the merry-go-round while the other guy is getting nauseous and dizzy. You know what I mean?
Yeah, exactly. It's the same perspective as like the star trajectory above our head, right? Type of thing.
Yeah.
We're not
it's
coming
the stars
around to it like they're going over us.
Yeah.
So I've heard the merry-go-round reference to that before, so that's why I mentioned that.
Yeah. You were talking about Coriolis effect, and that was often used.
Yeah, no, the star trajectory around the North Star.
Oh yeah.
It's like, okay, so people compare that to, oh well, the stars are just so far away, and that's Earth's spin, da-da-da, right? But it's like being on a merry-go-round, and the merry-go-round spinning. But if you had a light while you were on a merry-go-round, you would be coming around to the light instead of the lights just going over you like we observed. So it's just it's always going to have a contradiction when they're trying to explain Earth's motion. Like, I think that's their Achilles heel, is whenever you start asking for proof of motion, and then they start like, oh no, like
yeah.
And I'm not sure if you knew this or not, but I've done a few observations recently. I did one in Florida, I did one in Colorado a while ago, and then I did one here in New Mexico. So they say that stars going clockwise in the southern region of Earth is proof of Earth's motion, right? No, that's impossible, right? But I actually found out all you have to do is point your camera south, even here in the northern region, and the stars will go clockwise. So that being a proof that Earth is spinning, it's like, no, you don't have to go to the southern part of Earth, which they call the southern hemisphere. You don't have to go to the southern hemisphere to get the stars to go clockwise. All you have to do is point your camera south, and the stars will go clockwise.
Yeah.
The fact they use that as proof is just funny. It's like, no, it's not proof at all. Because I can do it here in the north, and I've done it in 3 different locations just to prove my point.
Yeah. Oh man, kind of bringing back all these memories. I was trying to talk to Jaron about that one a long time ago, and he's like, he couldn't get that one through his head for some reason. Just the whole thing. It's like, look, if I shined my laser on the ceiling and had it go from left to right, and okay, it's going. The stars never go from west to east. They're always going from east to west. That's not changing. Yeah, you change. You can turn it around, and all of a sudden now they're going to appear to go from left to right and right to left, but they're still going the same direction.
It's like this. It's going in the same direction. We look north, and they're going counterclockwise. And then we look south, and they're going clockwise. But it's still
Yeah.
going in the same rotation. It's still going in the same.
Yeah, exactly. I love that. That's awesome.
Yeah.
I'm glad that you have that just on hand. That's awesome.
Just had it laying around.
Talking to the right guy today. Yes.
Got my P1000 on the tripod. That was honestly not a prop. That was just there. I did a time lapse of the moon on the solar eclipse the other night, and it was really strange. What I found is that there were these lights that appeared above and below the moon. So what I did is I put it on the Star Trails mode, which is the 2.5 hour time lapse, right? So it has the long exposure, has the high atropure, so it does the trajectory of the moon. But these lights that were above and below the moon appeared, and I remember the video you did a long time ago with the guy on the airplane during the solar eclipse, and how there were like these orbs above and below the actual moon. So I'm wondering if that's what I caught the other night, and I didn't even mean to do it. I kind of just like went up and was like, oh, I want to see what the moon does tonight on the time lapse, and I looked at the footage the next day. I can send it to you, and there's like these lights above and below. It's like, it's really strange.
Yeah. There's a lot of weird stuff about the moon that I just don't understand.
At least we're humble enough to admit that, though. You know what I mean? Like,
Yeah.
I think that's the problem with the heliocentrists, is that they
Absolutely.
know everything, and then once we go poking holes in it, they're like, oh my gosh.
Explain this. Explain this. I'm like, I'm sorry. There's just so much about heaven that I just don't understand. It's beyond my realms. You know, when I get there, I'll let you know if I can. If you're up there with me, I'll let you. I don't know, but. Yeah. Oh, wow. So one of the things that really stands out to me when it comes to pendulums here is if they're supposed to be detecting earthquakes, wouldn't that affect things? You know what I mean?
Yeah.
Wouldn't that?
Well, what do you mean?
Okay. Okay. So if pendulums are supposed to prove the rotation of the Earth, then why don't we see the same effect happening on our seismometers? Are we detecting the rotation of the Earth, or are we detecting earthquakes here? What's going on? You know what I mean?
Nice. That's a good catch. Yeah, that's a good
Yeah.
contradiction you found. I like that.
So they're like, oh yeah, it totally proves this. I'm like, I thought this was detecting earthquakes here. Right?
No, it's funny, yeah.
They're totally fastened to the ground. That was something that Bob Nodell, he pointed that out a long time ago. He did a great presentation on this stuff, and he pointed out something called the Elias effect, ALLIAS, Elias effect, and researchers were noticing that during a solar eclipse, weird things would start happening to pendulums. So all of a sudden, they'd start speeding up and going faster, and I thought that was pretty weird.
Interesting. I didn't know that. Yeah, all kinds of anomalies happen whenever there's a eclipse. Last solar eclipse, or no, not last solar eclipse, the last annular solar eclipse, like, I felt all funny after. It definitely did something to me. And then they had all of those shadows that like had the eclipse in the shadow. Do you know what I'm talking about?
A shadow with an eclipse in. I'm thinking like a pinhole projector.
Yeah, so no, like any shadow, like my sister took a picture of a shadow of her van, and it had a bunch of little mini eclipses in the shadow.
I know what you're talking about. I noticed that in tree leaves. We're out looking at the tree leaves during a solar eclipse, and we're seeing all these little mini eclipses in the tree leaves.
That's crazy, yeah.
Yeah, it's something that we've been observing our shadows a lot lately. Every morning as I walk the kids to school, I'm always pointing out all the fuzziness on our shadows and kind of the weird things you can do with the penumbra on our shadows. And I've been drilling my kids. I've got one in first grade and the other one in fourth grade that I walk to school every morning. And every morning I'm asked, okay, what do you call the fuzziness on that shadow? And just kind of drilling it into their mind. Penumbra, penumbra. Why is that a big deal? Because the light from the sun is not parallel. They got to get through. Got to remember that one. Keep telling them it's really important because so much comes undone when you just acknowledge that little principle.
Mm-hmm. I'm not sure if you've seen the at-home experiment I did with my at-home lunar eclipse on the heliocentric model, and like proving that the shadows always get bigger, because I had the discussion with the NASA employee, the ground-based NASA employee. The ground-based NASA astronomer says that he ran the Hubble telescope and whatnot. I went into the NASA tent though, I know they were official, but one of his proofs, one of the things I asked him is that, if the diameter of the moon is this amount and then it's only casting a shadow that's this amount, shadows always get bigger. He's like, no, if the sun's rays are coming in parallel, then it'll go ahead and get smaller. And then I did like a little at-home experiment to prove like, no, that's not the case. NASA Bobbit, if you want to watch it, it's fun.
Yeah. Okay, I'll have to share that one on the Globebusters here. But yeah, if the light from the sun was parallel, there would be no penumbra. It would just be completely non-existent.
Yeah, exactly. Yeah, but the fact they say the pendulum is proof of Earth's motion, it's like, that's a pretty weak one they have.
Yeah. So I've got another video here real quick. All right. Hopefully the audio works on this one. Can you hear that?
Yes, sir.
Listens. Flat Earth Keys.
I thought it would be a good idea to start from the beginning and look into the manufacturers of the Foucault pendulums around the world, and as it turns out, I can only find one. Academy Pendulums, based in California. Furthermore, they appear to have a monopoly on the Foucault pendulum business, with a whopping 122 installations worldwide, starting as far back as 1951 through till 2011. There are more pendulums installed since 2011, but there is still only one manufacturer, so I'm pretty sure it is still a monopolized industry. Another interesting fact I stumbled onto was this. All of the Foucault pendulums worldwide that have been used as a scientific representation of the Earth's assumed rotation are all electronically controlled using magnets with a carefully timed kick, as the company states, to keep the pendulum in motion. That's right, a carefully timed kick to keep the pendulum in motion. I personally think that it is no accident that there is only one man in the world who personally manufactures the all-important electromagnet, and that it is no accident that there is only one manufacturer in the world of the only device known to science that can allegedly detect the Earth's rotation in a visible fashion for the world's population to see.
So that was it. I just had to share that with you there because I thought that was just really wild. All the different pendulums out in the world that they do these things in the museums at. I think they've got one over at the I can't remember what it's called anymore. They've got a big space museum out in Salt Lake. It's on the tip of my tongue. I just forgot what it was. Yeah, but they've got a big pendulum over there, but they're all manufactured by the one guy. One guy makes them all.
Yeah,
and
that's a little coincidental for sure.
Yeah, and they need to have electromagnetic rotors on it to give it motion. So that right there just falsifies everything.
With a push start.
Yeah, needs a push start, and it needs to be controlled. Give it a kick, and so.
But trust me, this is proof of Earth's motion, right? And then
yeah. If it was, then they wouldn't need all that.
Yeah, they would need all that as well. Yeah, I agree. Then I'm not sure if you've looked into like putting a vector on a sphere or a circle and then track the motion of the vector. It will do a consistent speed, right? But as soon as you make it do more than one speed, it has to slow down and speed up. So in some of these, you can actually detect the motion going half the speed it was as it's going around. So like this one, it was going 4 miles per hour, just going in one circle, right? And then you put it in another velocity going this way, and it went from 4 miles per hour to 8 miles per hour, 4 miles per hour to 8 miles per hour, and it slowed up and speed up like that much. It was, I think that's funny. Like that one fact alone destroys Earth's spin because there would be a consistent flux of motion, like
Yeah.
in just one rotation too. You know what I mean?
Yeah.
So just all the holes you start poking and.
It's getting me thinking about how different artists will hang like a paint can, like poke a hole in the paint can so it does designs on the ground. The big art project, just to get like the kind of a spiral designs on the ground with the paint. Pretty cool when that happens. But it's interesting
because the trajectory would be like, it would be that weird spirograph like trajectory, like shape. It's not just a consistent.
Yeah,
you know what I mean.
And it's not. Yeah, it's not the same every time you do it. There's you throw it in different angles, and it's going to have a different results every time. So, kind of gets me thinking about what you were saying there with the seismographs about how no two seismographs say the same thing. Like, well, you got to just throw it just right. Do you know what I mean?
It's silly.
Yeah.
Apparently, the ambient noise is another thing that affects the seismograph. Ground motion is consistently affected by non-seismic forces from both natural and human activity. A sensor near a busy road or airport will affect high-frequency noise from traffic. So that will affect the seismograph, but yet again, Earth's motion doesn't. So it's how many holes can we poke in this? You know what I mean?
Yeah. So have you heard anything about the Cavendish experiment?
Yeah, I looked into that a long time ago. It's been a while since I looked into it, but yeah, that one's pretty funny too.
Yeah, I've got a little bit here on the Cavendish experiment, and let me share screen on that. Okay, so here we've got two big bowling balls acting as our weights and some other things here. And this is something that Bob Nadell pointed out in his 2021 Flatoberfest conference. And he was showing this Cavendish experiment. This is Sly Sparking, and he's sharing this demonstration of it. And Sly Sparking is an anti-flat earther. He's like, oh yeah, this whole demonstration is supposed to prove gravity, mass attracting mass. There's no audio here except for some tapping noise. So this right here is kind of a significant thing that Bob was pointing out. As we saw the little balls at the end there, you've got a little silver ball at both ends. It gets close, and then all of a sudden it starts to retract. Let's see if it's kind of coming closer, and I don't think it's tapping. Oh wait, that one might have tapped. I don't know.
It's gravity, bro.
Yeah, it's supposed to be gravity. That's what its claim to fame is. It's coming back, but why would it be going backwards? Is the whole thing that Bob was pointing out. Why is it going backwards? And so this kind of was one of the many things that led to the whole electrostatics. It's kind of getting close to it, and then all of a sudden it's like discharging. It was kind of one of the theories involved there.
Oh, cool.
Ah, man, where's Kemi? Kemi, we need to talk to you about this. Maybe she's got some more insider information on that and stuff. But Yeah, I thought that was kind of a really interesting thing. But when it comes to this whole Cavendish experiment, a lot of people have done it in a lot of different ways. And I've got to look at this and I got to think about, okay, we're hanging weights from another cable, right? We got some string or whatever that is that's holding it up. And why wouldn't that be detecting the earth vibrations? Now we've got the same kind of setup for another seismometer. You know what I mean?
Yeah, right. Mm-hmm.
Wouldn't that be affecting anything? How do you rule out earth vibrations from that?
Yeah, that's a good point. Yeah, I didn't think about that. If a seismograph is proof of Earth, or if it's detecting an earthquake, but then at the same time a pendulum is proof of Earth's motion, but then Cavendish was using like 2 pendulums, why wasn't it working then, right?
Yeah, we got 3 things going on here, and we're getting completely different stories. You know what I mean? Oh, we're detecting the vibrations of the ground. It's an earthquake, and it's coming from this direction, and it's a pinpoint location right there on the ground because of the delay. And yeah, the other having a hard time. Well, why isn't this vibration looking exactly the same one over there? We've got all our mixed messages there, and then another person, oh no, it's proving the Earth is spinning.
and then you got another guy, hold on, it's proof of gravity.
Yeah. So which is it? Which is it?
Can you guys pick one, please?
Yeah.
That's funny.
So I'm kind of like looking at this, and yeah, this is exactly what Earth science is all about. Earth science is about seeing the bigger picture and putting the puzzle pieces together. And I was just talking with my daughter the other day when we were reading. I've got a new textbook that I'm writing. I like to say that you can't judge the only cake on the table unless you've got another cake on the table to compare it to, right?
Watch that.
Yeah. Until you've got 2 cakes for some actual comparison, the only cake on the table is the best cake on the table. And so that's inspired me to, I can't just criticize all these other textbooks. I've got to go write my own textbook and put that on the table. And so I've been doing that with my daughter lately, and it's been really fun, and just kind of getting her involved more and more.
That's super cool. How old is she?
She's 12.
Oh, 12. Cool.
Yeah.
Yeah, I feel like your daughter and my daughter would make good friends.
I know. And so next week I've got to make a plan to get them talking.
Yeah, right.
Yeah. So, yeah. So I wanted to share that with the Cavendish experiment, and I'm trying to remember if there's something else about this that was standing out to me too. Kind of looking at my notes. I know with pendulums, there's been other people who have noticed that there's inconsistency. So it's supposed to move along at a certain rate, and then all of a sudden, wait a second, it's not going at the right time. So maybe the electromagnetic motor on it isn't quite working right. But that was okay. I'm
That'd
sharing
be
to the wrong.
interesting to do a Foucault pendulum experiment like in a thunderstorm.
Yeah, that would be interesting.
Because you have the thunder, right? And then
you
have electricity, so I wonder if that would affect it significantly. Or like you said, during an eclipse already affects it, so it's interesting.
That's I'm glad you brought that up, because that was one thing that the textbook was actually talking about, was about how some waves can actually travel through the atmosphere. So during an earthquake, some of the waves from the earthquake end up traveling through the atmosphere, and that's why you hear it. When you hear an earthquake, you hear the rumbling, and yeah, it ends up turning into sound waves. And so that was something interesting. And so that right there tells you, when it comes to a pendulum or a seismometer, if there's thunder in the background, that can affect things.
Yeah. Or it should significantly, right?
Yeah, it should affect things. It should affect how the readings on the thing. I know that we looked at 2 different kinds of pendulums. One that kind of measures the up and down Let's see. I got to go back to the...
Like the up and down reading whenever it's reading the earthquakes.
Yeah, so where'd it go? Okay, here we got our up and down reading
Oh,
the
okay.
earthquakes.
Okay, yeah.
Okay, and then we got the horizontal kind, and that has to do with different kinds of. This is our college textbook over here, and it was talking about the P waves and the S waves.
Mm-hmm.
Both types of waves speed up in denser material and slow down when passing through material that is less dense. P waves travel through all types of material, including liquids and gases. P waves traveling through the atmosphere are responsible for the rumbling sound that we hear during an earthquake. S waves, on the other hand, can only move through solids. They do not travel through fluids, liquids, or air. Okay, so one of those waves we could, like a thunderstorm, we'd probably be able to pick that up on one of these.
Yeah.
That's something I thought was kind of interesting. And one of the points I made from last week is if these waves can't travel through fluids, how are they getting through the water table was one of my big questions. When it comes to these deep earthquakes that they're claiming happen way over on the other side of the planet, and they somehow are able to get through this.
Yeah, how is it getting through the water?
They're talking about this, these shadow zones, and that was something that really stood out to me too. Was I found the Smithsonian went and shared an article that kind of caught my attention, and so for a number of different reasons, and I have to share that with you.
Do it.
Okay. Okay, this is from the Smithsonian, and this might ring a couple bells for you. Okay. Is there an ocean below your feet? Okay. By Julia Rothschild. So right there, I'm like, what? Yeah, so bing! Some scientists think the Earth's oceans formed when icy comets hit the planet, but new research suggests different origin for the oceans. They simply seeped out of the center of the Earth. Huh.
Okay,
so this is kind of, so this here is the Smithsonian actually talking about like the fountains of the deep breaking open and pouring out the oceans, basically.
Yeah, right.
Yeah, and this is the Smithsonian saying that. Like, that's interesting.
Formed when icy comets hit the planet, but new research suggests a different origin of the oceans. That's crazy.
Yeah.
Mm-hmm.
The finding, but they're trying to say it's like in rock, and I'm not really fully understanding this part right here. The finding published in Science suggests that a reservoir of water is hidden in the Earth's mantle more than 400 miles below the surface. Like, yeah, how would you know that?
Right.
Yeah. But they're kind of talking about that, but they're talking about it being like stuck in. Yeah, there's a whole bunch of things out there going on right now about this humongous ocean that's underneath our feet. There's like a whole other ocean over there. But yeah, it's kind of weird that the Rothschilds are over here talking about that on the Smithsonian.
Yeah, and then they say the seismometers is how they tell us what Earth's mantle and core is made out of.
Uh-huh.
Right? I don't know.
Yeah.
Just it's so theoretical. Like
there's so much of it. Yeah.
Vibration, like, is telling me exactly what composition that it's going through. Oh, we've tested it outside of Earth's core. It's like, all right, but it's still theoretical because you can't prove it because we've only been, 7 point something miles.
Yeah, that was my question. Is when I was doing the research on finding out about this whole other ocean beneath our feet, because they're not the only ones who was talking about it. I saw some other people talk about that before them, and this is the one that just kind of stood out to me. So it was done by a Rothschild. Like, what? Yeah.
That's crazy. It
So-
looks like a piece of what is it? The Sky Stone.
Yeah, it does kind of remind me a little bit of that.
Uh-huh.
Yeah, this.
Sky Stone made out of what? 77.07% oxygen.
Yeah. Cammy, we need to talk to you about crystals. She's the gemologist who could tell me
Oh, is
more
she?
about this. Yeah.
Coming back on, Cammy?
I don't know. We'll see if her audio gets fixed. If not, we'll have to kind of bookmark this one for next week and talk about it then. So,
Worries.
man. So, yeah, it's called synthesized ringwoodite. Ringwoodite. And apparently it's got like water trapped inside of it. Like I'm seeing bubbles here. And Cammy was the one who was pointing out how they've got like water stuck in crystals before. And it seems to be something like that. But yeah,
I'm no
it's kind of
geologist, so
yeah. Well, we study Earth. That's what every Earth scientist, every flat earther is a geologist. So don't give me that.
I am part geologist.
Yeah.
Just
So-
not that type of rock formation.
Gemologist. Gemologist is, yeah, that's more Cammy's forte. Cammy and Karen, we're missing them both today. Oh, man. This is the week for them. But, yeah, we'll bookmark that and we'll have to talk more about that later because there's so many other interesting things there when it comes to that kind of stuff. But, yeah, I think there's... Do we have anything else here? Oh, I've just got Foucault's Pendulum, a video from... I don't remember who made the video. The Flat Earth School, and they're just kind of showing this pendulum that goes at the wrong time. Let me share screen there. Let's see if I can share that.
We are here today at Science Space to observe this Foucault pendulum.
Oh, I've seen this one, yeah.
The globe model claims that this device can be used to demonstrate the
So, yeah. Long story short is he's sitting here observing it, and it's supposed to go at a certain speed, and then all of a sudden, oops, it didn't follow that right speed. So I think we talked about that.
Turn up the motor.
Yeah, turn up the motor.
Give it a bigger push.
Yeah.
That's funny.
Yeah. So Cammy's over there in the chat saying hi. She's, yeah, but that. So we'll have to catch up with Karen and Cammy. Karen's got some in-laws coming over to visit, and yeah, she's like, "Oh, we gotta clean." Yeah, so I hear that. So
How often are you on this show?
I'm here pretty much every Thursday. So.
Okay.
Yeah, you're more than welcome to come back and talk with us more next week. Would love to have you back, and hopefully we can get my daughter over here and we can get our daughters talking. That'll be really fun.
Absolutely. Good job on the video you did in the, what was it, a high school?
It was over at the library. It was right next to the high school.
Oh, okay.
So-
Yeah, it sounded like a bunch of high school kids asking the questions.
Oh no, it was mostly adults. There was like a few like high schoolers, but yeah, it was mostly adults, and yeah, it totally filled the room. It was really fun doing the
No
whole
way, that's
debate.
fun. And then
Yeah.
none of the other colleges or none of the other professors wanted to debate you. It was just
No, I tried really hard. Like I even went like with the high school there. I went and emailed all the different like science teachers, and they weren't interested. It's just like, okay, well, I'm going to do this whether you want to or not. And and I ended up just turning it with the whole audience. And the really fun thing about that whole debate was they had tons of questions at the very beginning of the debate, but by the end, all of a sudden, they were speechless. And except for like in the very end, they had some like other questions for me. It's like, oh, how long have you been studying this? And they wanted to get to know me more personally after that. But yeah, but
After you
they didn't have any rebuttals.
Yeah. I guess after you knock out the basics, they're like, oh, I don't have anything unique else to ask you.
Yeah, tell me more about. Yeah, tell me more. And it was. Yeah, they were speechless when it comes to rebuttals after that. Yeah, that's been
good
interesting
job.
with that.
How did you end up like doing that? You went up to the library and you're like, hey, I want to do a flat Earth debate, or how did you approach him?
They've got a conference room, and I just reserved the conference room and just told them that I was going to do a public debate, and they're cool with it. And so,
Cool. So you didn't like specify what you were going to be debating?
They didn't ask, and so I'm not going to make it. They didn't ask. I'm not going to make a big deal about it. And
Cool.
but the people at the library know me, and they could have put two and two together pretty quick. But
Okay.
they had no problems with it. And my biggest thing was advertising in order to get the room filled, and that whole thing came down to me just making big signs. And there's no rule against putting up like a lost dog sign or anything like that, right? And so I just went and put up a whole bunch of signs on the street lights and around the library and kind of through town, on just letting them know when the big debate was. And we're like, what? Flat Earth debate here? And so that got people's attention. It was fun.
That's super cool. There needs to be more activists like you out there for sure.
Hey, well, I'm not alone.
Yeah,
I'm not alone.
Yeah, right?
Yeah.
Definitely not alone here. I'm doing my part in New Mexico. You're doing your
Yeah.
part in Utah, right? So, no, but if everybody spoke out, there would be a lot bigger of a ripple effect in society for sure. I think there's a lot of undercover, like flat earthers, a lot of people who haven't gone public with it. And I think that's the issue, you know? It's like, oh, don't be afraid to tell people. Like, I had a guy come up to me just a few days ago after I asked to follow him on Instagram so I can show him one of my daughter's videos. And he came up to me, he was like, hey, I usually don't like talking to people about this, but I sent you a bunch of videos on Instagram. I was like, okay. I was like, what are they? He's like, they're a bunch of flat Earth videos. I was like, oh, cool. All right, I'm down with that. I was like, how long have you been into that? Like, I've been into it like 3 years, but I don't like talking to anybody about it because I know the reactions I get. And like, don't get me wrong, I don't blame him. He runs a business and stuff, and I respect him as a person and everything. I just didn't know he was a flat Earther. I've known him for over a year. So,
Yeah.
and
That's
there's a
cool.
lot more people like that. Yeah.
Yeah.
Like more
That are just kind of, if they don't really talk about it, then you never know. And they just kind of come out of nowhere and just, hey, they'll talk about it once you start talking about it. And that's kind of how it goes. My daughter was talking about how the kid in her school just randomly said, the earth is flat. And then all of a sudden that inspired her. Yes, it is. And she got all excited about it.
Super cool. Super cool.
Yeah.
So I'm actually the captain teacher at my church for first through fifth grade. And I just introduced the instructor of L Kids, is what it's called, to biblical cosmology. And she like kind of went over the basic questions, you know what I mean? Like everyone does, but I'm not sure if she's 100% on board with it, but she's not like discrediting it at all.
Yeah,
You know
she's cool with it. She's cool about it, not total troll or anything like that, and
No,
just
not at all.
respecting.
Yeah, she's respecting. She's asking questions, which is good. So since I'm captain teacher, I was like, hey, this is a fundamental truth of the Bible. I believe the kids need to be taught. So I'm trying to get her to get approval so I can do a presentation to the kids. And I've already started it. I'm already 31 slides deep, and it's going to be super like simplistic. It's just sun, moon, stars, outer space, motion or lack thereof. What does the Bible say? And then what does men tell you? What does the Bible say? What do men tell you? And then have like my personal observations to show the kids like, hey, like you're being lied to, you know what I mean? And that's all it takes is one authoritative figure to tell them that they've been lied to, and then they'll wake up for the rest of their life. You know what I mean?
Absolutely, yeah.
They're so young, so.
Yeah, I think that's my big goal with my textbook is to just put as many sources as possible in there and show them, rather than I want to show them the actual results. I talk about these tiger traps or pitfalls where you have this false ground. It looks like it's solid ground, and all of a sudden you walk on it, and then it can't support your weight, and so you fall into this hole, right? That's a pitfall, but I call them academic pitfalls, where they make a claim and they do nothing to substantiate their claim whatsoever. And so I'm trying to do the opposite of that, and going into, okay, this is a claim, and this is exactly how we know it, and this is how you can see it for yourself, kind of a thing.
Yeah.
And so,
absolutely,
it makes a big difference to just build that strong foundation. It's been fun. So
I had one of my ex coworkers contact me the other night after I sent him the video I most recently made. It was from the Truth Is Stranger Than Fiction's channel. I just took
uh-huh.
2 clips out of his video. Outer space is faking gay, but I labeled it something else. He had like this big old title, but I sent him that video, and he's known I've been a flat earther since I've been working with him the past few years. And he called me. He's like, "Hey, I'm with my wife. We have some questions, and these may sound like some stupid questions, this and that." And then just went over like the basic questions. Oh, what about other planets? What about gravity? And you know what I mean? Where's the edge? Like just those funny questions. And I explained it all to him in detail. And then he's like, "Dude, this is all starting to make a lot of sense." And then,
Yeah.
and then his wife got on, and his wife was like, "Well, I really appreciate your belief on this."
She's scared.
And I was like, "This isn't like just a belief. This is something you can go prove yourself. Like, you can go measure Earth yourself." And she was like, "What do you mean you can measure Earth yourself? Like, how?" I was like, "Well, you get 2 locations, point A, point B. There's a certain rate that Earth is supposed to curve, which is 8 inches times the mile squared. And then you calculate that into the distance, right?" And then I told her about an observation I did over here in New Mexico. There's a mountain range that you can see bottom up from 98.9 miles away.
Wow.
100 miles away, and you can see the mountain bottom up. And then I've heard people don't like doing long distance observations on dry land, but all you have to do is just calculate in the elevation, right? Ironically, I'm 1,100 feet below the elevation of the bottom of the mountain, right? So there was 2 different ways of me doing it. It was either me pretending to build a tower that's 1,100 feet and then do the 8 inches times the mile squared straight to the bottom, or me at the bottom of my elevation to 1,100 feet below the mountain and then calculate it that way. And either way, the mountain should be obstructed by 1.24 miles of curvature, and you can see the mountain bottom up. And especially with the Nikon P1000, I've done it now. You can zoom into like the bottom of the mountain, and like it's all full frame, and then zoom out and just see it like basically vanish into the horizon.
You said you got this on video?
Yeah, I have a video on my YouTube channel.
Sweet.
Called,
I'll share it.
It's called The Mountain of Evidence in New Mexico.
I'll share that one in the thing after the show, and so people can see it. And, great stuff.
I think like after people realize, hey, like this isn't just a belief. This is something you can go do yourself. You know what I mean? Like that's when like the intimidation factor comes in. Like, oh, what do you mean? I can do this myself. It's like, yeah, you don't have to conform to authority and bow down to them and just listen to what they say. Go test it yourself. You know, like so. It makes things.
Cammy, is your mic working now, or can you hear us now?
It's working now. I can hear you.
Yes.
Now. I'm sitting here doing it, and I love it. That broke my heart that I didn't, because this was something I wanted to be on. I do not know what's going on with my iPad. It seems to work perfectly, except for when I go on StreamYard, it will cut out hearing anything where I don't hear things. And it's not my AirPod, because it doesn't matter if it's the speaker. It doesn't matter if it's this or earphones or anything. It just drops it, so I can see your lips move, but I can't hear anything. And don't get to enjoy the show very much that way. It's not very helpful. So it was better for me to drop out and end it. I love your enthusiasm and where you're going. It reminds me of where we were 10 years ago. And it needs to be brought back because when you talk about the mountains, that was some of the same things. I was in Denver, out by the airport, and I'm looking at Pikes Peak, and I'm doing the curvature formula, and it's like, again, things you can test yourself. And in the Denver area, we actually did with professional surveyors. We took equipment and, did a whole measurement and did complete precise measurement in that. There's nothing like doing it yourself. You can't have somebody else do it for you. You have to feel it. When you're catching them on the pendulum, we were doing that like 8 or 10 years ago too. And you're right. The pendulum, there's all kinds of different things to it. Bob went into many videos on it. Well, they actually have software and stuff in the pendulums now that keep it on track and keep it going that way. So they're set to do that. It's not what you think it is, nor do they work any way, shape, or form the way that you think. So yeah, the pendulums have been totally debunked. And again, most of them got a little engine in there, keeping them exactly on time. So it was fun to see like the ideas and the spins on that. And that's what we need is the fresh eyes and more people coming on to it like that.
Yeah,
It
we
warms.
absolutely love your energy. You bring so much to us, and so yeah, we need
Are you
that.
talking to
So
me?
yeah.
I,
Thank you guys. I appreciate it.
I love it's what we need is the fresh eyes and the fresh energy. I told Kyle what I'd like to do is I would like to ideally like take off the rest of the year. I've been doing this over 10 years. I've gone through a lot and my life has changed so much, especially in the last, 2.5 years since losing Bob. This is my passion. It was Bob's passion, but I'm tired.
Yeah.
um, I mean, I'm just tired, and yet I'm not. I look every day with the beauty, and I've measured it. It's flat. I have been working in the background on optics and things called real focal points, and that where I can actually with angles, and I've done it for different peoples where you can explain and look at different ways for southern rotation really easily through optics. I need people that can present it better than I can, but I've actually have been doing a lot, some really interesting work. I've never had a problem with southern rotation. If anybody has been watching my work, which some of it has been in past years called The Girl with Kaleidoscope Skies, I use only real physics and I have no problem with southern rotation. So I'm just throwing it out there. I will start presenting on it in the new year when the attitude and stuff has died out because right now it's like a battering match. And I find it ugly. I don't find that invigorating. I find your way of looking at things invigorating. Kevin, I find what you're bringing to the show. And so I want the shows to continue while I'm off with people bringing more energy and bringing what they do. I want to be able to just take time off, get my house really clean and in order, my paperwork filed, my spend time with my parents. My mom is in her 80s, and I won't have her much longer, so I'd like to go out and see her and just do some things. My
I
girlfriend
get
that's
you.
coming in
Yeah,
from Scotland, Liz the Iron Maiden, will be here in less than 2 weeks right now for like 6 weeks. So I want to regenerate, replenish, and be ready to go strong. Not because I'm giving up, but because I want to come back stronger. In the meantime, Kevin, I love what you're bringing. And again, please do come on our show and find ways to present and keep the energy going.
I appreciate it.
It's beautiful. I mean, the flat earth is beautiful. The children you are, oh,
Here,
I
look.
love it. Love it.
This is another southern hemisphere, right?
Hmm.
Oh, she has one
Just
too.
like,
We
oh,
have this on hand too. This is literally right here the whole time. So you do,
if I
right?
if I get more hands, I can get more of them. I have even more.
And then that's going this way. That's going the other
Hmm.
way, right?
Hmm. Let's.
Going like this.
I mean, this is well. I mean, I can try to do this. I don't know what we'll show on this, but
oh,
Do we lose her?
we lost her. She clicked on something, and maybe she'll come back. We'll see.
No worries. She seems like good people.
Yeah, but yeah, we'll be more than happy to have you back next week if you're game for it.
I will take it into consideration. Thursdays,
Okay,
my
no
day
problem.
off with my daughter, so I will.
No,
see
no
what's going
pressure.
on. Yeah, I appreciate
Yeah.
it.
Yeah,
Absolutely.
we have a family first motto over here. So
Yeah,
stuff
yeah.
happens, and yeah, so you take that. Yeah, and so bring her on. I'll bring my daughter along and get them talking. That'll be fun. We got
We can just have a kids podcast.
that'll be fun.
Okay.
Yeah, we're just talking about like getting more energy in here, and there's definitely energy that kids bring.
That's why I'm here is for the children. All of the stuff we can do with the children, and the things I can like even show them with the optics. That's if you see the children and what I do. anisotropic, the way we can show colors, the way we can show light and what it does. If you can give me the children, they turn around. I have children teaching Faraday effect at age 8, and I would love your children too can do it
It's fun
better,
teaching them like
better than
the bigger
better
the
than the
bigger words.
professors.
Yeah.
Better than the professors. No, they could go there and go, yeah, I can do Bell's theorem. I can do Faraday effect. I can, yeah. But no, I love working with the children, and for sure get the children on this show and that energy. You'll notice that when I tried to hit something, I blew it. It was not the button I was looking for. I don't know if I can find the button was looking for. Yeah. I was just gonna say, like with all of the different crystals and balls and different, yeah, we have all of the toys, all of the stuff here.
That's cool. Do you have any Skystone?
Um, I don't, but I've touched them. No, 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 no. I've touched them. I don't. That's no. If it's the skies come from which one? The one from Antarctica that I've read about. No, I haven't. But there is something called the
That one's
sky
supposed to
stone
be
that's
like
not.
ice, like really, really
Yeah,
cold.
yeah. That
Yeah.
that I don't know. There is something a sky stone that was like a turquoisey or something matrix that I've touched, but I don't have it, and it could be something different.
I think it's the one from Africa that I heard about. That's like
The
really,
Libyan.
really blue.
Um, Yeah, I'd have to look at. I'm trying to remember on it on the sky stones on it. Libyan desert glass. I have some of that, which some people
Oh,
have
okay.
said
Yeah,
is.
that's made out of silica, right? Or mainly
Mm-hmm.
silica.
Mm-hmm.
Very conductive.
Mm-hmm.
Hmm.
Oh, good. You do conductive, and you do. Oh, good, good, good. We can have fun. I think you're coming up with the speakers. I don't think my things are going correctly, but if you guys are okay, that would be fun to do too. Going into the different things, materials through conductors, non-conductors, and how a lot of them will change with temperature, which
No,
is
interesting.
fun, which is interesting. Magnetite, which I find is really, really interesting as far as electric conductivity. It's an excellent conductor when it's cold, but it's an insulator when it's hot. Now, none of the magnets that we make work like that. Ours are either conductors or insulators, be it the ceramic ones or the neodymium ones, but I find it nature. So a lot of the rules that we have packed on things, nature doesn't do that. Nature works so much smarter than we do. So much smarter.
I was
Same with
curious
the thing.
about if you knew anything about this ringwood rock that the Smithsonian was talking about. Have you ever heard of that?
No, what's that?
I could pull that back up. It was just
Oh,
showing
back
this.
up. I think I dropped off there. I think that's where my son called, and I had to run in for a second. And then I
Oh,
came back and
okay.
I heard gemologist, and it's like, yeah, that's me. Um, but keep in mind when you guys say these things in a gemologist, what I did look at mostly were pretty things that were cut up in people's rings, not what I love, which are like the rocks and the minerals and that. So I was working primarily with the fine stuff. So it's a little bit I can ID the like faceted and fine stuff, bonito white and corner repining, even rare things. But I'm not used to looking at things like this as far as like again, if it hasn't been put in a ring, I'm
Yeah, it's
learning
more of
along
like
with you.
jewelry kind of stuff.
Yeah.
Right, I'm
Yeah.
learning with you on those things too. So because when you say gemologist, people will say, "Oh, they pick up rocks and say, what is this?" And it's like,
It's not really jewelry. I don't really
well,
know.
no, and
Yeah.
and rocks with, I mean, and what I worked on, really, in all honesty, a lot of it was is people make things to look like things. So simulants and synthetics, and again within the pasadena, that it's not just ever
Real
looking
diamond
at it.
versus a synthetic one.
Right.
Yeah.
Right. So it's not a matter of just glancing it and saying it's that. It's putting it on the equipment. What's the refractometer? What's the, what I mean? It's not, it's never just holding it and saying, what's that? Even though, like with some things, rubies, certain things, it's kind of easy, but it's never the right thing to do. Never the right
Yeah.
answer.
Yeah. So this is the synthesized ringwoodite. I
Okay.
don't know why they're calling it.
Synthesized, we're going to right away talk about that because this is important. When people think of synthetic in the real world, you think of polyester, you think of fake things, right?
Yeah. Yeah.
Synthetic synthetic is a legal definition in gemology. catch this, a legal definition. So it's important to know when looking at things. When you have a synthetic, it means that it is laboratory grown and it is exactly the same chemical in every composition. So it's going to have the same hardness, it's going to have the same refractometer, it's going to have the same optical property. Everything is going to be identical except for the fact that it was grown in a laboratory but underground. And the way you determine the difference between them are like small growth markings, the way that they grow, the growth lines in that. You'll have a lot of the times they're grown in platinum foliar. I'm trying to think of the name of the container, and my mind is slipping right now. But and the little platinum container they do it in, it will pick up small chips of that. So little flecks of platinum, or little things like that to tell you it since that it was not grown in the ground; it was grown there. But a synthetic is the actual stone that you find underground. And again, the only difference is that we grow them here. Where
Okay,
this
so
is
the
really important.
synthetic is grown in a lab, and then there's the stuff that's actually grown underground, or
Right. Nature grows it underground, and everything that we can grow underground, be it gold, be it any mineral, we can do it. Sapphires, quartz, amethyst, anything we can grow underground, we have now been able to do in a laboratory. We can synthesize it. Um, what's fun about this, so therefore we're growing all of these rocks. And in fact, we can make fossils, we can do all of this. What I want to know why we're thinking about this is because we can and we do all of this in laboratory. And what my specialty was in gemology was I compiled a little certificate that says separating sophisticated synthetics. That means separating the things that are grown in laboratory that are really hard to tell from natural. It's a whole art. It's a whole art. So people like me, they let us see how it was grown in this. I want to know when the Earth took millions of years and these things took all of this time to grow. Why most of these things grow in hours, days, months, seconds. The metals crystallize so quickly in milliseconds we can't even stop them as the glass. Bismuth grows within a minute. I mean, these things grow quickly. So when we talk about this stuff forming over millions of years, I want you all to know that rocks are growing all around you all of the time. They're happening in riverbeds, they're happening in nature. Anytime you have a super saturated slurry, riverbeds, lakes, moist areas, misty, anytime you have that, you have rocks growing. They've been growing. It might take years for deposits to form over things when you have the calcium deposits and that, but the actual rocks and minerals, if the ingredients are there and the temperature there, they happen like that. So I'm just talking about as far as creation, over millions of years doesn't make any sense. Just like diamonds, when they talk about taking a piece of coal and squishing it under high pressure and turning a diamond, that makes absolutely no sense either for the fact that this is the same. It'd be like taking tinker toys and or a tree. You have a fast growing bamboo that grows quickly, right? And you have your ironwood that grows extremely slow, and it's more compacted, it's dense, just like a compact tinker toys, or again, the wood is more dense. It'd be like saying, hey, take this bamboo and put it under high pressure and turn it into an ironwood, okay? Take it and squish it. It's the same material, it's wood, but one grew quickly and one grew, again, those you have slightly different woods. I'm giving a kind of a bad analogy. You have to replace some things. But if they were the exact same wood, one grew really fast and loose like bamboo, it's like you can't squish it into a more condensed, just like if you had a big tinker toy tower, you can't condense it into a little tinker toy, you just break your sticks. Diamonds, when we tried to produce some under high temperature, high pressure, which we did do in the 80s, and I was there for it being old. Guess what we did? We exploded them for the most part. We found out that diamonds grow best under low atmospheric pressure, by the way, in reality. Why they don't tell people that, why they show them there. So these are some of the conspiracies and the lies, and how beautiful nature is that they tell us that all happened, it's over. and it's done. And yet, if you look around and go to riverbeds or go anywhere, you can see it happening all around you all the
Yeah,
time.
we did a crystal growing kit a little while ago. We got one from the store, and my daughter did it, and we're growing crystals overnight. It was pretty quick.
Exactly, overnight. And that things, crystals, like I found this in Utah. This is fluorite.
Uh huh.
Perfect. It came out of the ground this way, people. I found this in the ground. It's a perfect octahedron. We have stuff all over the things. So, like rocks are one of my big conspiracies. You started this with your that you brought up that I said synthetic. If something is synthetic, it's actually real,
Uh
but
huh.
made in a laboratory. If it's a simulant, it's fake. So you have a simulated stone, which can be anything. It can be plastic or glass that looks like it, or anything that looks like something else. If it's not the same material as a simulant. So CZ is a simulated diamond because it's not in the diamond family, whereas moissanite would be simulated. They're both their own stones, but they use them to simulated diamond, whereas synthetic diamond is a diamond grown in a lab. So whatever this stone is, which is your synthetic whatever, they grew that in a lab. So this blue material, keep reading my eye. I, I know. We thought the show was over. I'm sorry.
You're fine.
Okay.
Yeah, you're
No,
fine.
Kyle was calling you. What were you calling her? The
Gemologist?
gemologist?
Yeah.
Now I know
Yeah.
why. Very cool.
A piece is
But anyways, guys,
synthesized.
I don't mean to interrupt. I'm gonna go spend some time
Yep.
with my daughter. We're gonna go.
Yeah, no problem.
Okay.
Yeah, we're all good here. I'm all done. I've got nothing else to say. So peace. Thanks for
right.
coming.
Shout out to
Thanks for
We'll come back
love
and do
seeing you.
rocks
for
more.
having me. I appreciate you guys.
All right, love you.
Appreciate you.
All right,
Kevin,
love you,
come
bye.
back, okay?
I appreciate it. Thank you.
Okay, no problem.
Good night,
Bye.
everybody.
Good night.
Let's close her down. Though actually, I want to see that really quick. A piece of synthesized runewoodite, the blue material that may contain oceans worth of water and Earth's mantle.